what do you think a rational expression is? Now, these are both words that you've encountered this year. Rational is a word that you've encountered this year, and expression, of course, is another word you've been encountering. We've defined both of those this year. And so the way that we can know it is remembering, of course, expression means no equal sign, of course, right? But rational, remember, rational numbers were the ones that we could write either where we could actually write the decimal, or what ends up being even more useful in this case, ones that we could write as a fraction. Because a rational expression, it's actually an expression which involves one or more fractions. Now, this is optional notes here. You don't have to actually add this into your notes, but you can if you wish. But a rational expression is one that involves fractions. Oftentimes rather complicated looking fractions, and that's what we're going to be looking at today. Because those fractions that are involved in a rational expression, they can include monomials, binomials, and trinomials, of course, basically all kinds of different polynomials. And that's what we're going to be seeing. Today, the main focus is going to be on monomials within each rational expression. But you'll see tomorrow even we'll start integrating binomials and trinomials in there and stuff like that as well. And you'll notice also a lot of that vocabulary that we've been looking at earlier in the year, it starts coming back more now. Things like, what is a trinomial? What's a rational number? Things like that, yeah, they continue coming through. To start our practice, we're going to take a look at this problem and how we would actually go about simplifying this rational expression. And notice it is a rational expression because it involves fractions and there's no equal sign. Therefore, also an expression. So you'll notice that what we're presented with here is basically a multiplication problem. Now, this means we got to go back and remember, how do we multiply fractions? Do you remember how to multiply fractions? You hopefully got it in your head. Now, some of you right now are actually thinking of division. I can tell. Multiplying is the one where we just multiply straight across the top and straight across the bottom. So, let's do that. For the top, we're going to do 10x cubed times 9x to the 7th. That means I got to do 10 times 9, which is 90. And then x cubed times x to the 7th. Remember, when I multiply the x's, I add their exponents. So 3 plus 7 is going to give me 10. So that's 90x to the 10th. Over. Now I'm doing 4x squared times 15x. So 4 times 15 is 60. X squared times x is going to be x to the power of what?
3.
Yes, 3. Because we need to remember that the x is actually an x to the power of 1. Now that I have this answer, now that I've done the multiplication, I can reduce this, yes. And so we actually do need to do reducing. Now, remember when reducing, I want to look at the numbers all on their own. So 90 over 60. What can I divide both 90 and 60 by? I heard a couple different answers there. I think the most common one I heard is 10. So I'm going to go ahead and divide top and bottom by 10 here, which will give me 9 and 6. Now I take a look at the x's. I have x to the 10th over x cubed. When I divide the x's, what am I doing with the exponents? Subtracting, absolutely. And so I do 10 minus 3, which is 7. So then notice that's a positive 7, so yes, that x is still on the top. So we have 9x to the 7th over 6, but you know what? This one's being a little bit tricky for us. Because I can simplify this a little bit more. It's easy to see between 90 and 60 that I can divide them both by 10, but there's actually something even bigger, wasn't there? Yeah, I could actually have divided them both by 30, but I didn't see that at the start when I did my work, did I? I don't want to have to restart it. So you can actually simplify from this point. What can I divide both 9 and 6 by? 3. So you could just pick up from there and divide top and bottom by 3. And so when we do that then, we should end up with 3x to the 7th, and then 6 divided by 3 on the bottom will give me 2. Now that can't be reduced anymore. That is our final answer. Whether you go straight there or whether you take the intermediary step and then get there, either way is fine. Now, that method will work every time, but I do want to point something out in case you're a little bit curious. Because usually somebody starts wondering, yeah, but I could have simplified that at the start. Can I simplify them before I multiply them? Yes, you can. If you see that it can be simplified, you can go ahead and do that first. Now, you don't have to, as you've seen, but you can. Sometimes simplifying first will make your life actually a lot easier. Sometimes it might actually just add an extra step. Kind of look at the problem and decide what makes the most sense for you there. All right, next problem, same basic idea. Go ahead and write down this problem and work it through, please. All right, so for this one, we're still multiplying, so multiply straight across the top, straight across the bottom again, just like we did in the last one. And so on the top, 6 times 5 gives me 30. X to the 5th times x to the 4th gives me x to the 9th. Now on the bottom, 5 times 12 gives me 60. X to the 8th times x cubed gives me x to the 11th. Now that I've done the multiplication, I do the simplification. First look at the numbers.
10.
What can I divide both top and bottom by here?
10.
I see 10, but actually in this case something else is jumping out to me, right? Yeah, actually it's another 30, isn't it? Now, if you saw the 10 and started with the 10, that's fine. You'll just do it in 2 steps. But I do see the 30 right away here, so I'm going to do that. So on the top then, that gives me a 1, and on the bottom that leaves me with a 2, because 30 over 60 is just a half.
Yeah.
Okay, now I look at my x's. So I have x to the 9th over x to the 11th. Again, I'd be subtracting the exponents, right? But 9 minus 11 is negative 2. What's it mean when we end up with a negative exponent? Well, notice where we have more x's in our fraction. We have more of them in the bottom. The negative exponent tells you that the x squared is in the bottom, not the top. Now you'll notice what's left in the top though. We still have a 1 on the top. We took out everything from the top, but we still have to have the 1 there. Now since it is just a 1, of course it can't reduce anymore. This is your final answer. So you're good with the multiplication. Now let's repeat the process with division. All right, now this one is division. So that means we do have to remember our method for division. This is the one where we're going to flip and multiply. Or if we want to be fancy, we can say we multiply by the reciprocal. Which fraction do we flip?
The second one.
The second one, yes. Always the second one. It doesn't matter what the fractions are, we always flip the second one. All right, so the way your work should look. The first fraction stays exactly as it was. No change at all in the first one. But we do change the division symbol to be a multiplication symbol. And then we flip the second fraction. Everything in the second fraction flips. And then from there, it's a multiplication problem doing the same sort of stuff that we just did on the previous ones. And so we multiply and we end up with this fraction, 165x to the 12th over 70x to the 10th. And we then need to simplify that. Now looking at the top and bottom at the numbers, 165 and 70, looks like I could divide them both by 5. So I'll start there. If I divide 165 by 5, yeah, it's probably calculator time on that one. That ends up giving us 33. 70 divided by 5, that'll give us 14. Okay? So I divided both of those by 5. Now I look at the x's. So I have x to the 12th over x to the 10th.
33x squared.
12 minus 10 would be 2. Positive 2 means it's on top, because notice I have more x's on the top than I have on the bottom. So my x squared that I ended up with is on the top of the fraction.
Yeah.
All right, now I do want to check here. 33 and 14. Can I divide both of those by the same number?
No.
Well, if you're not sure, think about the numbers that go into, pick one. I'll go with the 14. What goes into 14? 2 and 7, basically, right? Does 2 go into 33? No, because it's odd. Does 7 go into 33?
No.
No. If you're not sure,
That's 35.
of course, get the times tables down. That'll help. But if you're not sure, you could break out the calculator. 33 divided by 7 is a decimal. So that means we're fully reduced. That is it. Your final answer. All right, so for this problem, you should end up with the final answer of just 3 over x to the 4th. You notice our number part ended up on top. The x part ended up on bottom. That's okay. That can happen. All right, now with this one, we flip, we multiply, we end up with this. We start reducing. The 168 over 42, there's actually a lot of things you can divide both of those by.
42.
But actually 42 is the biggest. Yeah. And so 168 divided by 42 gives me 4, so that's like 4 over 1. And then the x to the 9th over x to the 9th, well, 9 minus 9 is 0.
So you just like 4.
So do I have like an x to the 0 here?
No.
No. It totally canceled out.
4x.
X to the 0, by the way, equals 1, in case you're curious.
Oh.
And so that just goes away. And since then the x's totally went away, the fraction reduces to be 4 over 1. It's a lot simpler then to just write the answer as 4. So that whole thing just worked out to equal 4. So after we work all this through, and we go to start simplifying, 105 over 105, obviously I can divide them both by 105. The numbers just totally cancel each other out. Now I'm going to go ahead and just write in a 1 over the 1 for the time being, just to keep track of the fact that there's going to be a 1 at least someplace in there. And then I take a look at my x's.
At the bottom.
Okay? If I do 11 minus 12, I get negative 1. Negative exponent, remember, means, oh, it must be in the bottom. Because notice I have 12 on the bottom and 11 on top. So if I cancel out 11 of them, I got 1x left. So that means like x to the 1 on the bottom. But now, the way that I currently have this written, it's certainly not very clean, is it?
So
1 over 1x to the 1. Okay? Better way to write that. Well, the 1 on top still has to be on top. But 1x, of course, is just x. So I can just write the bottom as x to the 1. And of course, x to the 1 just equals x. So the whole thing just equals 1 over x. And I'll actually center that just to make it look a little tidier. That's your whole answer right there. It's just 1 over x.